Thank you for the introduction. And I want to say thank you all for joining me last day of the summit, last talk of the day. I'm the only thing standing between you and happy hour, so I appreciate you all joining me, and I promise to reward you with copious amounts of code. So let's set the stage. What is this talk about? So at a really high level, we're all here because we like working in this world of big data. And you can attack this from many different angles. So there's the analytics angle, there's the systems engineering, there's data storage, and there's so many skills in this field. But one theme that emerges across all these various skill sets is efficiency. And so there's efficiency in the sense of, did I partition my data right? Did I pick the right executor memory settings? But there's another type of efficiency that we don't always talk about that's really important to me, and that's creating efficient systems that are efficient for developers to work in, efficient to create new features, efficient to onboard new people to your system. And so I have a real-life use case of having to build a system at Target, an on-demand computation system, that was kind of prone to issues of messy data, which we all see. And so it quickly became clear that we needed to develop a validation framework. And so I want to talk about how we did that and how we built this efficient system to work in using some Scala programming constructs. We were able to build this system to fit in line with the Spark style of using functional programming paradigms. And in general, we'll talk about tips for organizing code in production systems. So who am I, really quick? I'm a lead data engineer at Target. I'm coming up on my 2-year anniversary. I have a deep love of all things Target. My love of Target goes back 2 decades now when one opened in my rural hometown in Maryland. So I was able to recently combine my personal love of Target with my career when I relocated to Minneapolis. And it's been really exciting to be at a place I personally love. As a consumer, as a shopper, with a place that's doing all of the work I like to do with building high throughput backend systems. And so I was lucky enough to start working in Spark at the startup before I joined Target and have continued working in it. And like Target, Spark has also been a love at first sight thing for me too. So here's the agenda that we're going to follow for the talk. First, I'm going to go into the motivation. Why did we need to build this validation framework in this system? I'll talk about how we did it with Scala's Enrich My Library pattern. I'm going to go through an example end to end and then talk about other uses for the concepts that we're going to see today. So motivation, let's dive into it. So code, I promised it. Don't worry about internalizing everything that you're seeing here. I'm going to use this example throughout the entire presentation and break it down. But I just want to highlight that this is kind of what Spark code typically looks like as I've built more and more of these systems and developed more and more Spark jobs. So I really like to work in the dataset and RDD API. I like to build case classes and rely on strongly typed objects and use the fact that Spark can serialize case classes. So we all work in these different worlds at our companies. So you might work in the world of cars, passengers, drivers. You might work in users, posts, comments. I work in the retail world, so I have items, stores, sales to deal with. So for the next 20 or so minutes, let's pretend we all work in a world where we're developing a system that has authors, comments, and articles. So we produce content, and we're trying to do some deep analytics on our content. So I tried to provide an example here of what some Spark ETL code might look like for that. And so you can see it reads like a book, at least I think it does. So you load your author objects, you load your article objects, you load your comments. The first couple lines there, you're doing some filtering, some mapping, joining these data sets together, munging them, massaging, getting in a good format. And then towards the bottom of this method, it looks like, hey, we're going to get this ready to do some analysis. So we're flattening out our tokens on the comments that are associated to an article. We're counting them, bubbling up, and then you can imagine that down the road we're going to do some analysis, maybe some sentiment analysis to see what users think of specific authors based on the comments they're providing on their articles. And so, great, we have a starting point for a job. What happens over time when the system grows in size and complexity, and we need to inject more custom code into the mix? And you think, rats, I have this great code, it's pretty readable. Do I have to rip all of this apart? Do I need to kind of create these variables that are subsets and then inject my custom code and kludge it all together? And then we're also thinking, can we keep things concise, readable, efficient, and kind of maintain this functional style of programming that Spark lends itself so well to? And let's take a quick pause and do a functional programming refresher. So we talk about it a lot at this conference, but I just want to remind everyone, this is what I view the 3 major tenets of functional programming. But it's declarative in style, so you're declaring what you want to have happen, versus imperative, where you're saying exactly how to do it. So in Spark, when you say map on a data set, you're saying, I don't care how you go over all of these items in this sequence, just do your magic, make it happen, and I'm not going to worry about the details. And so the next tenet of functional programming that's important is we favor composition with functions. And so that's functions in a purely math sense. So you have a defined input, defined output, and then you can kind of string these functions together. And then I think the third, one of the most important things about this style of programming is you avoid shared state, mutability, and side effects. And so it lends itself to a what you see is what you get code base, where you can trust that when you're stringing all these functions together, weird stuff isn't going to happen that you don't know about. All right, so let's get back to the motivation for this validation framework. So at Target, I was tasked with building this on-demand computation system that was going to consume various data sources. And so we often talk about, building an on-demand, near real-time system or a batch system. And this was kind of sort of in the middle of the two. And what was really interesting about it is that there was a person on the other end of it. So we wanted to expose a way to generate insights for business users that they could kick off from a UI. They'd push a button. They were okay with waiting on the order of minutes. The system would run and then produce insights and give it back to the user. And so it's really important that we give them a good experience. So Target is a brick and mortar store. It predates technology. It was founded in 1902. So technology is relatively new to Target. The people, the process, the art of retail has been there long before Spark. And so getting people excited and onboarded into these new systems requires us to kind of create a really great experience and dazzle them a bit. So it's not really dazzling if this back-end system churns for 30 minutes and then fails cryptically and then bombs out with like a big red error on their screen. So it became immediately clear that I needed to find a way to fail fast if something was going to fail, get as much information as possible back to the user, and kind of codify all these different ways that the user inputs could cause a poison pill situation for our system. So yeah, so I think one theme that arises in this field is there are many ways for data to go wrong. Maybe one of the first things you learn in like computer engineering 101 is code defensively. Things go wrong, they always do, you can count on that. And that also translates to the world of data. Data always goes wrong. You can't predict what's going to happen and when it's going to happen, but you just need to be ready for it when it happens. So this validation framework, it needed to enable us to kind of build something resilient that would fail in a predictable way. So this was my dream. This is what I wanted to have happen. I wanted to be able to sprinkle validate calls throughout our existing ETL code in a really readable, functional style of programming. And I thought, is this possible? Is there any way we could do this in Scala? And so if you look at exactly what I'm trying to validate here, I have a data set of articles. That first validation, I wanted to check, do all articles have text? And if you go down a couple more rows, I want to check, is the data an expected size? And I'll assume that whatever machinery is going on in the background is codifying that somehow. And if you keep going down to the bottom, I want to check, are there enough comments for useful insights? And maybe if something isn't met, then we kill the program, that we're not getting anything useful out of it. Let's stop running, let's stop wasting resources. So I started to look around and try and understand how can I do this in the constructs of the Scala programming language. And it turns out that this is possible using Scala's Enrich My Library pattern. So let's talk about this in a little bit more detail. So I pulled some screenshots here from Scala's official documentation on the left, and we'll just kind of talk through it together. So it's a programming pattern that allows you to augment existing APIs. There are analogous features in other languages. It is also known as Pimp My Library for Googling purposes. This is how it started out, and then people thought, hey, maybe this is a little offensive, and then it got rebranded to Enrich My Library. But if you guys are curious about this, you can Google both things and find a wealth of information out there. And then I would just say it's basically syntactic sugar that uses implicit classes to guide the compiler. And so you can see from our example on the left here, it's probably easier to start from the bottom and then go to the top. So if you go to the bottom, we've imported this helpers object. And in the console, you're doing 5 times print line. And you say, wait a minute, integer doesn't have a times method on it. How is that possible? And so if you look up, this is the point. This is what implicit classes do. They let you augment existing types with new methods. So that implicit class there, int with times, doesn't matter what it's called. What matters is the first parameter to that class, x integer. And so that tells the compiler what you're trying to augment. So any methods it finds in that class definition, it knows it can tack on to that type. And so we use this concept to go down the path of building a validation framework. And so I'll back up a second because I know we have a diverse group of people who work in different languages. So really quick, what are implicits? So Scala supports a keyword called implicit that allows you to do exactly what it says. It allows the compiler to implicitly make connections at compile time as opposed to explicitly having to call a function or feed in a variable. And Scala supports 3 or 4 styles here. You can do implicit values, implicit parameters, to methods, implicit functions, and then finally implicit classes. And if you worked in Spark Scala, you've already seen flavors of this. So when you start out building a Spark job, you create your Spark session, you mark it as implicit, and then a lot of the Spark APIs implicitly take that in all of their method calls. And so you don't have to feed this Spark session into all of your methods, it just kind of auto-magically gets picked up because it's in scope. And so what is an implicit class? This was introduced formally in Scala 2.10, which is actually kind of a while ago now, although it's possible to achieve the same effect in previous versions using different constructs. So let's go through an example together. Let's talk about how we built this validation framework using these concepts. So how do we go from this, our big long block of ETL code, to this block where we're able to sprinkle validate calls throughout the code base and not rip it apart, keep things really nice, simple, and concise. So first, I started out by building a validation class. So this is an abstract class. So you don't have to do this to use Enrich My Library, but this is something I wanted to do to enable this validation framework. So you can see it's a class that is typed. This is another Scala programming construct. So you can generically type your classes and then reference that type throughout the class definition. And so there's some basic metadata that we want to keep about a validation. So we have a name, a description, whether it's enabled or not. I wanted the ability to toggle these in a data-driven way. If something was misbehaving, it was too expensive, we could just turn it off. So that was the point of that. And then finally, an outcome. So maybe a validation fails, and it's not the end of the world. It can keep going, but maybe you want to warn your user, hey, take this result with a grain of salt because we detected something weird. Or maybe you want your outcome to be abort because something's in a bad state, your output is not going to make sense. So I'm going to throw an exception and kill your Spark driver. And so if we continue down this class, we see that there is an abstract method called execute that you expect all of your concrete subclass implementations to fill in. And then you can see the signature on this. It's going to take in the type T that you typed this abstract class to be, and it's going to return that exact same type. And so this is very functional in nature, this style of writing methods. And this is kind of the meat of the validation. It's binary in nature. When you execute, it's either going to succeed and return back the exact same thing you gave to the method, or it's going to fail and throw an exception. And then underneath that, there's a perform validation method. I left out details to make this more concise, but you can assume this is a concrete implementation within this abstract class that is going to call into that execute method. And this is important for the next step of this process. So this is where we're actually going to use the implicit class to augment existing types in Spark. We can just go through this in a little bit more detail. It's only a handful of lines of code, but there's a lot going on here. So I want to reiterate that this class can be named anything. It doesn't matter. What's most important is the first parameter to it. That defines what type you're augmenting, what methods you're going to tack on to this type. So it has to be nested in a package or object. You can only have one parameter, like we just said. You can pass in extra parameters if you need them through the implicit parameter list. And then let's kind of talk about this because it might not be immediately clear, because I'm telling you I'm building a validation framework to validate Spark datasets and RDDs, but there are no datasets or RDDs defined here. And so what this is saying is that we are going to tell the compiler that you can augment a type T with the method validate as long as someone passes in a validation that is also defined for that type T. So this allows it to be really flexible. You can define validations for datasets of articles or datasets of comments. And this, like 4 or 5 lines of really concise code, is what is going to glue that together and allow you to call validate in your ETL code. And if you look at the actual validate method itself, it's kind of taking over control of the code. So in the ETL code, the dataset that we were working with, we're kind of stringing together these Spark API functions. So we're doing map, filter, join. And then we call validate, and it's taking over. It's giving control to the validation to call perform validation, and then handing control back over to continue using Spark APIs. All right, so the next step of this process is to actually define a validation. So one of the validations we wanted to create was all articles have text validation. And so you can see we extend our abstract class validation and we type it for a data set of articles. And so this says that anytime you see a data set of articles, you can call validate on it as long as you pass in an instance of this case class. And it's going to kind of direct you to this code to actually execute a validation. And so these kind of all took on a really similar pattern over time. You know, we have to fill in all the metadata about the validation, the name, the description, whether it's enabled or not, and what we want the outcome to be. And then the most important part is filling out that execute method. So this is typed for a data set of articles. And so the execute method needs to take in a data set of articles and then return back a data set of articles. And the pattern was really similar as we started implementing more and more of these. We'd tend to cache our input data set. We developed filters to tease out what the bad data was in that data set, if any existed. We'd materialize that count and see if it exceeded a threshold. If it did, throw an exception, otherwise return back the exact same features that were fed in. And you say, wait a minute, that's not going to work for me because I deal with petabytes of data. And so this worked for our case because we were using kind of medium-ish sized data sets. But I can imagine, you know, people using huge data sets where doing a count is really going to be kind of prohibitive. So you can kind of imagine, you know, this is really flexible. You would just kind of want to think, how can I suit this to my purposes? Maybe I do some sort of sampling or get approximations. So I think there's other ways to take it for kind of more extreme cases. And then again, I'd like to highlight that this is a really small amount of code to do something pretty powerful, and it's nice and isolated. So I didn't have to hack apart my job to kind of get this logic in there somehow. It's nice and tucked away in its own little class. So next step of this process is you create an instance of your validation and you pull it into scope. And so this combined with that implicit class, really it ties it all together, and this is what allows you to call validate inline in your Spark ETL code. And then I'd like to also caution, don't forget unit tests. So I talk about building efficient systems for developers to work in. This is probably the best thing you can do for yourself over time, is cover everything with unit tests when possible. And so you can see by separating this out into really modular code, it's also more isolated and easy to test. And so I really like using Scala tests fun spec style of testing, so it's BDD style. And it reads like a book. So like I was mentioning earlier, doing validations is binary. It's either going to work or it's not. And so this reads, when all articles have text, you return the original data set. When some articles don't have text, it throws a validation exception. And so, you can do some work outside of this class to start a local Spark in memory. And then you can use implicits to, create data sets out of sequences of example data and then demonstrate the positive and negative cases. It's pretty straightforward, not too much code. And we're done. So we've been able to develop concise, isolated, and testable code that can fit seamlessly into existing Spark jobs. Data is messy. It's always going to be messy. I don't think it matters how great a data quality project is. There will always be issues. And we have the ability to address this problem in an elegant way. And then I'd like to just say that this Enrich My Library pattern has allowed us to extend Spark APIs so that we can stay true to the functional programming paradigms that Spark uses. And then I just want to highlight ideas for other uses. So one thing being code organization and readability. So we have this long block of code. I think it's readable, but maybe someone else doesn't think it's that readable. So you can kind of envision a world where you can move these kind of blocks of related code together into implicit classes and name them more descriptively. So you can see in the example that we've been running with for this presentation, the first chunk is basically grabbing all your data, munching it together, augmenting it, getting it in a good state. And then that second chunk there is actually turning it into a different format, flattening out tokens, getting counts. And so moving all those pieces into implicit class and method definitions could turn into this, where it would read articles, augment with comments and authors, convert comments to token counts by author. And so that's way more readable than the left side, even though I don't think the left side's too bad. All right, and then another thing is once you keep building these systems, you realize there's really common things that you want to do. So validations being one of them, that's what we addressed today. But in these systems, you also want to collect metrics. You want to do logging, you want to do checkpointing, you want to do notifications. So you can envision a case where you could use these concepts and build out frameworks for these other core things you do in production systems. So here's my disclaimer. I was worried when people realized what I was going to be presenting today that there'd be a loud collective groan, people would throw things at me, and then people would run out the door. So thanks for not doing that. Some people call this monkey patching in other code communities. It can be a little mysterious, a little magical. So I would say use this stuff sparingly. Use it where it really helps you gain in productivity and efficiency, but don't go crazy with it, because no one wants to be stuck debugging really cryptic and esoteric problems in production systems. So final takeaways, we'll repeat one more time. Enrich My Library enables concise, clean, readable code. It enabled us to create a framework that has really rapidly sped up efficiency and development on our team. And the resulting code is isolated, testable, and easy to understand. So quick shameless plug for Target. I love Target. I hope all of you love Target. Come work with me at Target. We're hiring, just like everyone else out here is hiring, but solve real-world problems in the retail space. And we have offices in Sunnyvale, Minneapolis, Pittsburgh, and India. And I just want to say thank you. Thank you, Spark Summit, for having me. Thank you, Target, my longtime love and current employer. Thank you, wonderful team members. You guys are awesome to work with. And thank you, vibrant Spark and Scala communities. We don't code in a vacuum these days. People ask questions in forums and write blog posts and give talks, so thank you guys.
And thank you, Anna, from the crowd as well. Questions? Yes.
Hi, nice talk, thank you. One thing is you mentioned that one of the things that you value the most of functional programming is this: what you see is what you get. So in such case, sometimes implicits can be seen as an anti-pattern for such. And I'm wondering if you have explored the path of using explicit decorators instead of implicit, and just instantiating your decorators in your code and making explicit that you're decorating it.
I'm sort of missing the last part of your question, but I think I'm going to repeat it back. So you're saying that, I talked about functional style being what you see is what you get, and implicits is kind of an anti-pattern to that because it's more mysterious and magical. And you're saying kind of what do we do to mitigate?
If you have explored explicitly decorating your instances, you can get your data set and just explicitly decorate that and call whatever method you have in your decorator on it.
Yeah. First, I would say that I think it can be made a little bit less magical by keeping your imports as close to possible, like where you're using this code. There are some languages where you don't have to do imports, so you don't know where the heck this stuff is coming from. So I say keep imports close. But to answer what your real question is, I tried to look at doing this explicitly by like extending data sets, and there's a lot of like crazy typing stuff in Spark if you go through the source code, and we would run into like type like covariant and invariant problems. And so it seemed like a dark path of despair. I didn't go too far down it, but that's not to say that there's not a way to do it. I feel like there's 100 ways to do anything you want. So I'd say I'd love to find out, if there's a way to do this in a different way.
Hi. So do you have any recommendations regarding how we can implement similar functionality in a language that doesn't have implicits, like, say, Python, and implement it in an elegant way like this?
Yeah, so I've seen this a little bit before in Python environments, but mostly in the way that caused me great pain and suffering. So I'm pretty sure you can kind of set you can set methods on objects at runtime. But I haven't worked in Python in a while, so I don't have kind of a clear path laid out in my head. But I know there are similar ways to do this in the Python world. So you would kind of Google for like open classes or something like that. You'd probably want to Google for because this is a big theme in the Ruby language. So you can be like, hey, I'm working in Python. How can I get open classes like I have in Ruby? So there's a lot of discussion out there about this and why it's good or bad.
I mean, that was sort of related to my question, so I can offer part of an answer to that, which is Py4j is a tool that I was shown to do it with, and it's not pretty for you as a developer, but for the users, it feels a lot like working in Scala at that point.
Oh, okay, interesting, awesome, thank you.
First of all, this is the best breakout session that I've taken.
Oh, awesome, thank you.
Okay, so in terms of implicit thing, I don't find it successfully do it in Spark, because sometimes executor do not pick it up. Do you have the same problem?
So you can use that one part.
The implicit class, when you use it in the Spark world, sometimes executor do not pick up properly.
Oh, it does.
Do you have the same problem before?
Not really. So I tend to organize my Spark jobs so I would put the Spark job all in one class nested under an object. And so you kind of create your Spark session up front as an implicit, and it would be available in scope. So I think if you're doing a lot of object-oriented stuff, you might lose that availability to the scope. So that might be something to investigate if you can kind of put things more flat on an object. Yeah.
Maybe I failed to do implicit classes.
Mm-hmm. Yeah. Yeah, no problem.
Hey, so quick question, so if we're using data frame or data set in Spark, so Spark has a query optimizer, so you're gonna push down those operators and try to optimize your queries. So, but if you, by adding those implicit function, does that gonna have any impact on the query execution plan?
Yeah, so this for sure has impact, because Spark is a just-in-time lazy evaluation execution engine. So anytime you're doing counts, you're materializing data and you're forcing Spark to generate a stage and kind of a breakpoint. So it's not that this is not without overhead. So that's why I wanted to make it data-driven, where you can enable or disable validations. So for certain contexts, maybe we'd always want to run them or we wouldn't. So there's definitely overhead that's incurred by running these. So it's not, non-negligible. I think you just kind of have to figure out what works for your solution and what's acceptable, catching issues versus, your performance and speed.
We're going to take a last question if you have. Make it short.
Hi, so I'm not a Scala programmer, so I might be a bit off on this, but you mentioned logging, gathering analytics, and then you also mentioned that we might want to turn these off at some point, right? So it seems more like cross-cutting concerns. So did you consider any aspect-oriented approaches, perhaps like macros or something like that, instead of having a API that augments classes, and then if you have to make changes, you have to make changes everywhere?
Yeah, that's a good point. Yeah, I didn't really investigate that, thoroughly for this case. I thought, maybe you'd want to log some, statistics on these data sets. But yeah, I think, there's always 100 ways to do the same thing, and some are better than others. So, I think it's a great point, something to be investigated. Maybe this isn't the right approach for logging, but something else is.
Well, give a big hand to Anna.